So as I mentioned earlier, I'm going to be giving a brief overview of the requirements and how each thing that I presented in that demo traces to each requirement. So for some of our disclaimers, obviously we were really constrained by time and by money, and since we were both of us programmers were working full time during this semester, we were only going to focus on a select few components to design and release. This really is a software prototype, and really the focus of our project was on the software engineering process as opposed to the actual implementation of the project itself. So that's why we went with something a little more simple, and we didn't actually interface with, say, a sprinkler or a thermostat, just because of the added complexity and the time constraints. This really led to the project that we chose. Um, we did end up designing the system in such a way so that these flags were generated, and using those flags later on, we can actually interface with a temperature, with a thermostat or with something along those lines, with a water sensor or a water sprinkler system. So we really set it up that way that we could use that in the future. And then, in addition to our constraints, we did use entirely open source tools and software. There was no closed source implementation that we used. Everything was available online from either GitHub or some Linux repository. Everything, or PyPy was a popular one that we used as well. The central components did operate in a dry indoor environment. Obviously, if you're putting that temperature sensor outside, it's going to be in a little more volatile. The temperature is changing a little more often, but our temperature sensors were able to withstand that, and so that wasn't an issue for us. The system had a cost of no more than $150 to $150. Yes, if you look at the bill of materials in our report, you'll find that it costs $75.75. And the system should be designed and released in less than 2 months. Yes, it was. We really got the ball rolling on our project right around the end of the midterm, and that was when things started to really pick up for us. So for the functional requirements, we needed to set a control flag to water on days that don't rain, set the control flag to water when the moisture level is low, set flags to maintain comfort level based on external temperature, internal temperature, and the weather forecast, and accurately read sensors with a range of 10%. So if you remember in the demo, there was a little bit of delay with reading the sensor, but that's probably because we were reading it so fast. So we would say that this requirement was met because, based on our testing, we were able to determine that the temperature of the basement was about 67 degrees, and as you could see, we were measuring about 68 there. The control flag to water on days that don't rain, you could see when we switched the pins over from one to the other that we were actually able to, when we switched the water sensor from the dry dirt to the wet dirt, we were able to actually read and say, okay, the dirt's now wet, we no longer need to water. And since it's not raining tomorrow, then therefore, we were able to water. We also disabled the season feature for that module for demonstration purposes, but there was a season feature there as well. And we also were able to maintain the comfort level based on the external temperature. You can see that when we had moved the temperature sensor from the heat lamp to inside, that the set temperature was actually changing. For performance requirements, calculate changes to make every 10 minutes. Yes, we were able to do that. As I mentioned before, we were reading things at a rate of 3 seconds just for demonstration, but our actual system is going to operate at 10 minutes of an update rate. Make changes within 30 seconds. Yes, you could see in the demonstration that our update rate, when it was 3 seconds, the set temperature would then update about 5 to 10 seconds after that. So it was an update, able to update in 30 seconds. Warn users of error within 5 minutes. Yes, it will. A little error icon will appear in the bottom left when a sensor read error has occurred. And I didn't demonstrate that, but it will do that. For the API interface, we do have, so the system should make requests to an external API to retrieve weather data. Yes, it does. It interfaces with the Dark Sky API. API requests are made twice daily. Yes, they are. Weather data should be stored and organized. Yes, they are. If you consult the design document in our final report, you'll see that the weather data is organized into a class structure where we get specific subsets of variables, and they're organized really neatly and for the processing that we need, at least. For sensor interfacing, it does interface with a temperature sensor, and it does interface with a moisture sensor. And so those were the two things that I explained earlier. where we use ADC and SPI for the moisture sensor, and we use just standard GPIO for the temperature sensor. For the temperature control, we take two inputs, one from the indoor temperature sensor and one from the outdoor temperature sensor, and we are able to adjust the internal temperature settings of the house. So the temperature sensor settings were actually there on the screen, and you could see that just based on our general algorithm, we were able to change the setting of the temperature based on whatever the outdoor temperature was reading. When the weather's colder, the set temperature should increase. When it's cooler, it should not, and then it should not change. This is defining our comfort zone. So the comfort zone is defined as a 5-degree tolerance beyond. So the set temperature plus or minus 5, the system will kick on if the indoor temperature then exceeds or falls under that comfort zone. And our system also does have a night setting that adjusts the temperature based on whatever the current setting is. So this was hard to see because we were filming this at night, but when the setback occurs, we actually set it back 2 degrees based on the fact that it's night. And we define night as being between 9 a.m. and 9 p.m. or between 9 p.m. and 9 a.m. in a given day. In hot weather, the temperature will increase, and in cold weather, the temperature will decrease. So the set temperature in the summer is about 75 degrees. It wasn't shown, but once it gets to 75 degrees, that will then be its constant state and temperature that it sets at. And then when it gets to winter, 65 to 68 will be its approximate range, depending on the time of day and depending on certain external factors as well. For water control, we do take input from the weather forecast, and we do take input from the moisture sensor, and we also call for rain, or since rain was not called for in the forecast, then we are able to water the lawn. You can see that when we inserted the soil or the pins into the soil where it was dry, that it said yes, we should water. When we inserted into wet soil, it said no, we no longer need to water, the soil's okay. And then so the temperature never reached below 50 degrees Fahrenheit, but it actually would cut off the water module entirely when it's during the winter and when this condition is reached. So when it gets to 50 degrees, it will no longer water the soil regardless of any external factors or dryness or anything along those lines. And then for the GUI, you actually were able to see that we have system information available. So whatever the temperature control module is outputting, whatever the water control module is outputting, it also displays weather information, the current weather information, as I had explained. It also displays information about the forecast for the next 12 hours and the next 5 days, and it also displays current system statuses.